Hi, I'm Dr. Jeff Pettis, and I'm very pleased to be part of ApiSlovenija, the meeting in Slovenia, which I hope to have attended in person, but because of COVID, obviously this is not possible this year. So I hope to see you in the near future. And I'd be remiss if I didn't talk about the importance of Slovenia to beekeeping in general. And my good friend Peter Cosmos and his dedication to ApiMundia and his work as acting president and continuing as vice president with ApiMundia. So I thank you. Big shout out to Peter. But again, I'm glad to be with you, and I'm going to start and talk about Varroa here in a minute. And then I'll join you at the end of this presentation live, and we'll try to answer some questions. So I appreciate the opportunity to speak to you, and I hope that in the near future, we'll be able to meet in person, face to face. I'm coming to you live from my office. It's at nighttime when I'm recording this, but I'll be live whenever we host the real meeting in Slovenia. So I'm going to start, and I'm going to share my screen and begin the presentation. And start this presentation. So again, it's a real pleasure to be with you, but I wish we could be together in person. It would be a much better interaction. So I was asked to speak to you about Varroa. And in preparing for this talk, I decided, well, Varroa is important, but I wanted to take a slightly larger view and talk to you about some of the other pests that affect honeybees. And so I've served with the Office of International Epizootics, OIE, in Paris, and they regulate the safe movement of pests and diseases around the world. So I'll first talk about what pests are listed with OIE and what pests are not. Then I'll talk about Varroa history, how we got Varroa, how Varroa began to infest our bees, our European bees that we manage. I'll touch a little bit about Varroa biology, and then I'll talk about Varroa control. And finally, I'll conclude with a bit about selection for resistance to Varroa, which I think is in fact the ultimate solution when we have bees that can resist Varroa or tolerate Varroa. So that's where I'll end. No, I won't end there. I'll then talk about this exotic pest that comes from Southeast Asia, which has not yet moved around the globe, which is the Tropolailaps Mite. So these are the pests that OIE, Office of International Epizootics in Paris, list as notifiable in honeybees. American foulbrood, European foulbrood, Varroa, tracheal mites, which you've kind of forgotten about, Tropolailaps species, which I will talk about, and small hive beetle, which could be coming to an apiary near you. No, small hive beetle continues to spread around the globe, and we don't understand all the ways that it's moving. But a recent publication by my friend Peter Neumann suggests that it may be wax, unfinished wax moving out of Africa that has moved small hive beetle around the globe. That's one idea. American foulbrood and European foulbrood, I'm sure you know them. Both are bacterial. American foulbrood being very contagious and the spores are long-lived. I won't spend time on them. Small hive beetle, I'll only talk about them and tracheal mites in terms of how small hive beetle in particular is a new pest and it's moving rapidly around the globe. Whereas tracheal mites is an older pest. And the reason it's still listed by OIE is that there's still a few places in the world where we don't find tracheal mites. I'll spend most of my time on Varroa destructor, the Varroa mite, and also then Tropolailaps at the end. I'll spend a little bit about this Asian mite that hasn't moved around the globe. Just a little bit about EFB because it's actually becoming more of an issue lately, and we don't understand why it's so virulent of late. This is just a map from some work where it's almost found globally everywhere in the world, maybe parts of Africa. Perhaps we don't have good information there. But in any case, it's Melissococcus plutonius is a bacteria that gets in the gut of honeybees and they die in the larval stage. And the symptoms are fairly easy to recognize. But the problem is we've been seeing more and more of that in Switzerland, England, even in the US. And in some cases, in the US at least, we associate it with blueberry pollination. But there's heavy fungicide use in blueberry pollination. So we don't know if it's a nutritional issue or whether it's a fungicide issue. And I know from, I was in a year in Switzerland, and they're having significant problems with European foul brood. And they're actually burning either entire colonies or entire apiaries to keep it under control. So I only bring this up in that some of our older pests and problems are still around and they still are problematic. European foul brood being a good example. Okay, there's a number of things that aren't listed by OIE. You see a picture there of sac brood virus. The reason we don't list viruses yet with OIE is the diagnostic tests and some of the field symptoms aren't always unique. With sac brood, it is. It's very distinctive, this sac brood appearance. But with many of the other viruses, we don't have a good symptom in the hive. Nosema is no longer listed by OIE. And it's simply because we used to have Nosema apis, was very common, and we knew how to deal with it. It was a winter disorder. Then we got Nosema cerani. Now we have a couple of new species of Nosema being named. But regardless, Nosema is believed to be widespread. And once a disease becomes very widespread, OIE no longer lists it because their mandate is to keep things from spreading globally, to keep them from moving to new areas where they're not. So Nosema was delisted from OIE some years ago. Crithidia is something you may or may not have heard of. Lochmeria, the same. It's an internal, there's some gut parasites of honeybees that are coming in being talked about. Also, you know about viruses, deformed wing virus, DWV in particular, its interaction with Varroa can be problematic. And even in Slovenia, the Asian hornets are there's one species in France. It's now moved and expanded to Great Britain and just into Italy. So the Asian hornets are expanding. And we actually had Vespa mandarina in northern US in the Washington state. So these pests are moving around, and OIE, their job is to try to set up guidelines for testing and detection and how to deal with them, how to control them. And they list these 6 different species, but there are many species that are problematic that we're not listing. And these are just some examples of that. So let's move on to talk about the colony and disease prevention. And we're going to get to Varroa here shortly. But as we've domesticated bees and we moved them into apiaries and we crowd them together, disease problems become more apparent. When bees live in the wild and they're 3 or 4 kilometers apart, the nest, disease transmission is not so big, but we tend to put things in apiaries or in bee houses, and disease transmission is very easy. So then we become the caretakers of bees. I think honeybees can exist very well on their own, but again, as we crowd them, as we domesticate them, we become more of their caretakers. Again, so how does diseases and pests move around? Well, this is an example of robbing, extreme robbing in an apiary. So robbing is one way, drifting of bees between hives. We as beekeepers moving combs around between hives, we move American foul brood and things like that. And even things like our equipment, our hive tools, we know can move diseases and pests around. But bees can also be managed in what I'd call even a more sustainable way. These are clay hives in Egypt, modern clay hives, modern meaning that in the modern day. And the beekeeper simply, when the swarm moves into that clay tube, they make a entrance and seal it over with mud, and the bees exist quite well in there without any management, or without little management. The same is true in parts of other parts of southern sub-Saharan Africa, where they put out log hives or bark hives, and the bees occupy them. They make honey. They require very little management. So those, I would say, more wild type bees can exist very well on their own, or seem to be doing quite well on their own. And it was when we got the movable frame hive, the movable frame, which allowed us to go in and examine hives and look at disease, and then move bees more closely into apiaries, when we began to see more and more disease problems actually in reality. So I think one of the things as a beekeeper, one of the first things that we can do is learn to read that brood pattern, learn to look at how the queen is laying, the solidness of that brood, and what the bees are provisioning in those combs. Learn to know what healthy brood looks like and recognize when the brood is not so healthy. That's a very key ingredient for managing good bees. So what are the two things that you can tell from this brood frame? You take a minute and look at it. I think the main thing is, overall, I'd say that's a good brood pattern, could be slightly better. But then if you look, there's no band of pollen. Let's see if my cursor will work here. Yeah, there should be a band of pollen right here around the edge of the brood. And while there is nectar, this is open nectar here, there's really no band of pollen. They're very pollen poor, at least in this case. Now, they had pollen in order to make that brood. All I'm wanting to point out here is that when you go into a colony, what I do when I go into a colony is I read the condition of the colony by looking at both the brood pattern and then what they're storing and how they're storing it and what's going on. So we finally get to Varroa. Sorry, that was a long buildup to get to Varroa, which is what I was asked to speak about. So I want to talk about a little bit about the history of Varroa. So where did the mites come from? They came from Asia. And they came from Asia because their natural host is the Asian honeybee, Apis cerana. And I think that's shown here. Apis cerana is the original host, and they've moved over to Apis mellifera. So this is Apis cerana. They've moved to Apis mellifera, the European honeybee. And the first report of that was a movement from Japan to Paraguay, I think, of queen honeybees or something. And that was the first report where Varroa jumped from Apis cerana to Apis mellifera. And this is a Japanese beekeeper that I visited. Was lucky enough to do a sabbatical in Japan for a while, and seeing they keep in these interesting single brood boxes, and they do put supers, but they manage both Apis cerana and Apis mellifera. But trying to understand how Apis cerana deals with Varroa and how Apis mellifera does not deal very well with Varroa, a number of us researchers call that the holy grail of understanding Varroa. If we could figure out how Apis cerana was not affected by Varroa, then maybe we could apply that to our Apis mellifera bees. And finally, Page and colleagues, Peter Neumann and others, in 2016 found out what they call social apoptosis. And what that means is Varroa normally like to reproduce on drone brood. So this is a drone pupae, and the Varroa's there reproducing on drones. Well, who cares about drones, right? I mean, we do care about drones, but if they parasitize drones, it's not that severe on the colony. It's when Varroa infests worker brood that it becomes problematic. And in Apis mellifera, they readily infest worker brood. And there's some evidence that it's a certain line or clone of Varroa that's been able to figure that out, how to infest worker brood of Apis mellifera. But the key is back here in Apis cerana, Asian honeybee. When Varroa goes into a cell with a worker cell, when Varroa moves into a worker cell of Apis cerana, the Apis cerana bee larvae / pupae dies. So it's called social apoptosis, meaning social death. So the worker brood of Apis cerana, when it's infested with the mite, it dies. So now the mite dies with it, And that's huge selection pressure for the mite not to move into worker brood. So Page and colleagues figured that out in 2016. Now, the problem is we thought that would help us in our Varroa control. It's interesting biology, but we don't think our European honeybees have that same capability. So when Varroa moves into Apis mellifera worker brood, the brood doesn't die. So even though we figured it out, we've solved this, what we thought was the holy grail of understanding Varroa. It doesn't help us right now, at least in Apis mellifera. And I'll say a bit more about that in a minute. This is some Apis mellifera being managed in China. And I throw this in just to show that Apis mellifera is not supposed to be in China. It's not, doesn't naturally occur there, but beekeepers manage it around the globe because it produces more honey. And these are Chinese beekeepers managing Apis mellifera, European honeybee. The catch is it takes more management, it takes more control measures to control Varroa. If they managed Apis cerana, the Asian honeybee, they wouldn't have to use as many control agents, but they do. OIE is set up to prevent things from moving around the globe. And we can set up walls, we can set up customs agents, we can set up all kinds of trade barriers, but pests and diseases continue to move. And that's because we have a very robust global trade. And I want to point out just two new pests that have moved recently. Well, OIE lists small hive beetle. We've already talked about small hive beetle and how they're moving. And I think it's related to wax. I think Peter Neumann and colleagues are right. That is unprocessed wax where the small hive beetles are present and the eggs are larval, probably larval stage, and the wax moves around and then they move around the globe. This is the one, this is an Asian hornet, or one of the ones, this is in Thailand, I believe. But these hornets, at least 2 or 3 species, have moved around the globe. And that's primarily just due to trade goods. So we can have all the laws we want and all the barriers we want to importing these things. But I use this to illustrate what I think is the best defense. The best defense against these new pests is you, the beekeeper. You're in your hives all the time. And when you notice something different, you need to talk to someone and say, hey, this is unusual. I have these maggots, I have these larvae reproducing in my hive. That's how we found small hive beetle. The colonies were being overrun with larvae, and it was the larvae of the small hive beetle. Or you see something that looks unusual, it's unusual kind of wasp or beetle or whatever. Talk to somebody, talk to an apiary inspector, and because you, the beekeeper, are the best line of defense against these pests and diseases. Okay, so finally we get to Varroa, the Varroa mite, Varroa destructor. It used to be called Varroa jacobsoni, and Dennis Anderson, who you'll see in a minute, he's an Australian researcher, he renamed it, and it's a great name because it is very destructive to our bees. You already know it. I don't need to show you, but for other people, it's pinhead size. Here it is on a drone pupae. Here it is showing the transmission of viruses, deformed wing virus. And it's easy to recognize in the colony. The only thing you can confuse it with is Browla, the bee lice. And that's actually fairly easy to do if you have Browla in your area. It reproduces in the brood, in the developing brood in the colony. It feeds on brood, but it also then feeds on adult bees. And so there's a time when it's reproducing in the brood cells and cap brood cells. And there it is feeding on hemolymph. But there's some recent research by a group out of the University of Maryland. When it's feeding on adult bees, it's actually feeding on the fat body of the adult bees. There again, that's a new finding. It's interesting, but it hasn't so far helped us with control measures. Trying to understand the biology, we know that in the larval and pupal stage, when it's feeding on hemolymph. it goes back to the same site and just feeds repeatedly at the same wound site on the larvae of pupae. In the adult bees, it attaches on the abdomen and feeds on the fat body. In general, if you have very susceptible bees, susceptible honeybees, your colony, in a year and a half, you'd have the Varroa mites overtaking the colony. This is not so true when you get some natural selection going on. And that's what we'll talk about a bit more in detail. We know that the mite transmits viruses, deformed wing virus being one of the ones, but there's a whole host of viruses that are worse when you have both the virus and the mite present. So this is a typical growth curve for honeybees in red in a northern hemisphere, where in the springtime, the bees begin to grow, and they grow very rapidly. And during that time, the mite level stays kind of low because the bees are just reproducing extremely fast. But through the summer, as the adult bees begin to drop off in number, the Varroa mites are still reproducing, and they go through this almost exponential growth curve in the fall, in August and September. And if you're not applying, if your bees are susceptible and you're not applying some kind of control in spring or here to midsummer, you will get this exponential growth curve, and the colonies will often collapse. So that's just a kind of stylized thing about how the mites increase in the fall in general in the northern hemisphere. And again, I'm not going to tell you the timing of when these treatments I use in my own operation. I use formic acid and oxalic. I use formic acid in the spring or summer to keep the mite levels low, and I use oxalic out here when the colonies go broodless. That's all I use. So how can you detect the mite? Well, you can look for the mites on adult bees, but by the time you begin to see them on adult bees, the mite levels are pretty high. So I don't think that's it's not really a very good way to look for Varroa. I think a better way is to either do what we call ether roll test or the sugar roll test, sugar shake test. You take about 300 bees in a jar, shake them out, and you count the number of Varroa, and you just estimate the amount of bees by using a uniform scoop size. And you know this, but anyway, it's a fairly simple way of getting an estimate of how many mites per adult bee I have. And recommendation is some people go down as low as 3 mites per 100, or 5 to 10 mites on 300 bees is an action threshold you need to treat. But that depends on your area and the susceptibility of your bees, I think. Things like screen bottom boards, you can use a screen bottom board and get natural mite fall to get an estimate of, and many of you may be doing that. And again, in a 24-hour period, if you're getting more than 30 mites dropping naturally, your colony might require treatment. Again, this is all based on local experience. It's going to change with every location around the globe. And I can't tell you what to do exactly in Slovenia. But I can tell you that if you use what we call an integrated pest management approach, use a variety of techniques, you're going to be better. You're going to be better off. And I think the very first thing you need to use is some kind of selected stock. I know you're keen on carniolan bees, but even carniolan bees that you have will have some resistant traits that they can develop to Varroa. And then use other methods, look at mite levels and only treat when necessary. So, and if you're going to treat with a harsher chemical, even with oxalic acid and formic acid, you need to rotate things. Or if you're going to treat with a hard chemical like amitraz or fluvalinate, don't stay with the same product for several years. Rotate chemicals, because you will get resistance. You will get resistance to those miticides. Again, these are some of the more organic things. Apiguard and Apilife Var are both based on thymol, and you know these, I think. I use only the organic acids. I use formic acid in a slow release gel formulation, and I use oxalic acid when the colonies go broodless. Obviously, I can't tell you when you should apply in Slovenia. Those are things that are locally dependent on temperature and the growth patterns of the bees, things like that. What I can say is I do sugar roll to determine if I need to treat at all. So I do sugar roll tests and say whether, oh, the mites are okay now, I'll wait and do it later in the summer. So, and again, there are these other harder chemicals like apistan, which is fluvalinate, apivar, which is amitraz, and things like that. They can work, but they tend to be residue forming in your colony. There are what we call cultural control, screen bottom boards. There's some effect of having a screen bottom board where the mites fall through and don't come back up. It can be very minor, but it's also been shown that when the mites are partially resistant, if using a control compound, the mites are knocked down but not killed, the screen bottom board can increase the efficiency, so because the mites don't get back in the colony. Resistant bee stock, I think, is the ultimate answer, and there's a number of work going on around the world to do that, and you may be doing some of that yourself in Slovenia. Drone brood removal is a little bit time consuming, but it does work, and it's simply based on the fact that Varroa like to move in the drone brood preferentially. So in the spring, especially, the Varroa are going to move into the drone brood more readily. You cut out that drone brood or freeze it or whatever, and you've eliminated a lot of the Varroa population. It's a very simple technique, a little time consuming, but it's simple. There's other cultural control things. If you make colony divisions or splits or nucleus colonies, whatever you want to call them, and you take the parent colony and you divide it, move some of it out and start it with a new queen, both the nucleus colony and the parent colony will have lower Varroa populations than if you left the colony alone. So one cultural way of just helping to reduce your Varroa buildup is to make splits in colonies, especially through the spring and early summer. It reduces the mite population both in the parent colony and in the split. So now what I want to get into a little bit, I won't have time to discuss them all in detail, but all these things you see listed there, these are all possible resistance mechanisms to Varroa. And I'll as you read those things, I'll tell you that, think about it. It's unlikely that Apis mellifera, that our honeybees are going to rely on a single mechanism to totally resist Varroa. And yet, that's what many of our selection programs are based on. So we'll base a selection program just on hygienic behavior, or this VSH, Varroa sensitive hygiene, which is VSH. There's a new one called recapping behavior, and I'll talk about that. There's a group in the US looking at only bees that damage mites, that groom them off and bite them. My take on all of this is that it's better to have a holistic approach and get a bee that will survive with Varroa, and it might be a bee that's using multiple approaches. So I'm going to talk very briefly about each of these, but not go into detail. But I'll have some information where you can go further with these if you like. Hygienic behavior, you may already be doing testing with that. It's where you simply, in this case, it looks like they've used liquid nitrogen. They put let's say a can around here. They poured liquid nitrogen in this area and freeze killed this section of brood, and come back 6 or 24 hours later or 48 hours later, and they read how many cells of this dead brood have been removed. This is fairly hygienic. Almost everything's been removed except these few cells. This would be non-hygienic. So they freeze killed this whole area, and yet much of it was not removed. So these are non-hygienic bees. There's also a very targeted type of hygienic behavior, which we call Varroa sensitive hygiene, VSH. And VSH means that they recognize that the Varroa is in the cells, and they uncap it, and they either remove it or yeah. So it's more targeted than just general hygienic behavior. And there's a lot of effort going into Varroa sensitive hygiene bees as well. But again, so this general hygienic behavior, one beauty of general hygienic behavior, it's very simple to test for. You can do it in your own bees that you're selecting. It works really great against European and American foul brood, chalk brood, and a little bit against Varroa. So if you have bees that are unselected and you start selecting for hygienic behavior, you'll get some resistance against American foul brood, European foul brood, chalk brood, and even Varroa. So hygienic bees do tend to remove disease and dying larvae very well. And Varroa sensitive hygiene is one good trait that we know confers partial resistance to Varroa. This other behavior that I wanted to talk to you about, I actually got the chance to work with the group in Switzerland on, and it's recapping behavior. And I point out a couple of, Melissa Oddie was the first author here in Scientific Reports 2018, and Stephen Martin and colleagues have done some follow-up. But basically, the worker bees are walking around, they investigate a cell, they suspect that there's a Varroa there, they open it up, they uncap the cell, there's the investigating part, uncap the cells, and then they recap the cells. So, and I've got a picture down here, I'll show you in a second, but they can either recap the cells or they can remove the brood. Removal of brood would be like hygienic behavior. They actually remove it. But this recapping of the cells, I don't know how well you can see this. This is the capping from a worker cell. And when they originally capped it, it was a light tan in color. Here in this little circle, they uncapped it. They cut it open, looked in, like they're doing here. They uncut it, looked in there, and then they recapped it. They actually put new wax and closed it back in. And you can tell this if you, with a lot, very tedious work, but you look at this capping, you can tell it's been recapped. Like this one was opened up and then they closed the capping back up. We don't totally understand what all is going on with this recapping behavior, but bees in Norway and other parts of the world that are showing these high recapping behavior traits are showing resistance to Varroa too. But again, it's one of many traits that I think confers resistance to Varroa. And how does it work? Okay, they uncap here. The Varroa mites are in this cell, and something about uncapping and opening up the cell and then recapping it, it disrupts the Varroa, so they don't reproduce as well. Anyway, it's complicated, and I don't think the full story is finished on this one, but it is that recapping behavior does tend to confer some level of resistance. Okay, another way is bees biting mite, literally biting them or grooming them off their bodies. And this is just supposed to show some pictures. They have 8 pairs of legs, and in many cases, the bees themselves bite and damage the legs. So you can look for damaged legs and look at the proportion of damaged mites versus undamaged mites. And the more they damage the mites, the more the mites will die. So it's a good trait. And that's, let's call it grooming behavior or mite damaging behavior, something like that. Another one that's been talked about, worker bee development time. And that we think may be playing a role in Africanized bees, where they develop in the seal brood stage a little bit faster. So instead of taking 21 full days, they emerge in, let's say 19 or 20 days. And by doing that, the mite doesn't have as much time to reproduce. So bees of African origin, the African subspecies, tend to have no problem with Varroa. We have some of those in the Americas, and we have those in Africa, and they never treat for Varroa. They never have a problem with Varroa. So what is special about African bees? Well, one thing may be this development time. But again, so development time is one option. Also, maybe African bees are better at grooming and damaging mites. There's a lot that we don't understand about mechanisms of resistance in different populations of bees. But so that's going to bring me to my real conclusion about selection for bees that are mite tolerant or resistant. Blackier and colleagues in 2019 talked about this Darwinian black box approach. And what he said in this paper was, you breed from local surviving stock, and you really don't need to understand the mechanisms of resistance. You don't have to get in there and test for everything in the world. What you need to know is that those bees survived with mite populations, and some bees didn't, they died out. So you breed from the survivor stock, and you don't have to understand the mechanism of resistance. And this goes back to how, even in history, the British sailor, I think the example he uses in the paper, but I'm not sure, the British sailors were getting scurvy. They were confined on ships for long periods of time, and they were getting scurvy. But the ships that happened to have citrus or limes and things like that on board, the sailors didn't get scurvy. So somebody made the association, citrus, feeding on citrus equals no scurvy. They had no idea about vitamin C. They had no idea how it interacted. But for over 200 years, they started putting limes and other citrus on board, and it cleared up the scurvy in the British Navy. So you don't have to understand the mechanism of resistance to just see the result. The result of selecting from survivor stock will give you bees that tolerate Varroa. And it also is very important to think about, they're probably not using just a single mechanism. They're probably using multiple mechanisms. So breed from your best stock and breed from those who have the lowest mite populations. It's pretty simple. It's not, doesn't happen overnight though. Doesn't happen overnight. So this is Dennis Anderson, a colleague of mine from Australia. And he did a lot of work on Varroa, understanding Varroa and which Varroa we had. And he's the one that renamed Varroa destructor. But also he did a lot of work on this other mite that I'll talk briefly about, and it's called Tropolailaps Mite. And it's a parasitic mite that's very similar to Varroa, but so far it only occurs in Asia. So I'll spend a little bit of time on that. Is it really still confined to Asia? I think so. And this photo that you'll see a couple of times is from a good friend of mine, Umberto Boncristiani. And you see the mite pictured there on the late larval stage. This is like a fourth instar. The cell is about to be capped over, and the mites will stay in the brood cell. This is just like Varroa. Varroa move into a brood cell, and then the brood cell gets capped over. This is just like Tropolailaps. This mite is very similar to Varroa in that way. The original host for this Tropolailaps mite was the giant honeybee, and it's two species, Apis dorsata, Apis laboriosa, the two giant honeybees. They build a large single nest. This is one on a tree, and this is a couple of different nests on a very large Buddha in Thailand. There's one on the ear actually, but they build this huge nest, but it's a single comb, and this is the host that we think Tropolailaps mites evolved with originally. Somehow, then they've moved over and they're infesting Apis mellifera, European honeybees that are managed in Asia. But guess what? Just like with Varroa, the Asian honeybee, Apis cerana, is not very much affected. So Tropolailaps, you can find them in Apis cerana colonies, in Asian honeybee colonies, but they don't do much damage. But where our European bees are managed in Asia, this Tropolailaps mite is a big problem. So this is a picture down here. This is Varroa. That's the Tropolailaps mite. That's a bee's wing. This is a bit of wax. They're all the same. Because if you're working on sticky boards, they're really hard to tell apart. But you can see they're half the size, at least half the size of Varroa. And they're more or less confined to Southeast Asia still. This is a distribution map from a publication, I think in 2005. There were reports, I'm looking for my cursor. They're mostly Asia. There were reports from Africa, which have never been validated. The same here in Tanzania. Tasmania. Tasmania. Probably they still are confined only to Asia because we don't have them spreading other parts of the world yet. They reproduce in the bee brood, as I pointed out, just like Varroa. They go into the cell, then the cell is capped over. The one really big difference is the adult mites spend most of the time either on the comb or in the brood. They're almost never found on adult bees. So unlike Varroa cling to adult bees and feed on adult bees, Tropolailaps mites don't. So the only way you detect them is by looking on the comb, for them running around on the comb, and they move very fast, or looking in these cells and looking to find them in the cells, just like Varroa. They can't survive very long away from brood. We think that they don't feed on adult bees at all. There's no evidence that they feed on adult bees. So if you have colonies without brood, they don't tend to survive very long. Another thing that you can pick up if you happen to visit Asia is what I call bald brood, B-A-L-D, bald brood, like bald head. Meaning, let's go back. They uncap. So the worker bees uncap this. If you look in these cells, you'll almost always find Tropolailaps, whereas the neighboring cells, there won't be mites. The beekeepers in Southeast Asia know when they start seeing this, they start seeing bald brood, it's a sign of Tropolailaps mites. But the odd thing is that they don't recap. So unlike Varroa, in Varroa they recap. With Tropolailaps, they don't recap. So they tend to leave them open. What's the other thing that you've ever seen in your colony where they don't recap and you see this bald brood? There's another condition in honeybees that I've seen many times. It's wax moth. When wax moths are burrowing along a line, along the midrib of the comb, the middle of the comb, you'll get this line. It's always almost in a straight line. You'll get a line of bald brood. That's the difference. See here, there's no pattern. I mean, you don't see a pattern. It's just scattered. This is Tropolailaps. So don't worry when you see bald brood in your bees. It's probably wax moth. It's not Tropolailaps. We hope it's not Tropolailaps. Okay, so I was able to do some work in Thailand on using Varroa control products to see if they worked on Tropolailaps. And it was kind of telling. HopGuard, which you know is a thymol product. There's HopGuard. HopGuard is a thymol product. I use a formic acid product, a slow-release formic acid. I use Amitraz Apivar, which works very well on Varroa, and a few other things that I tried. Well, you can look at the paper, but I'll tell you the take-home message. The take-home message was formic acid worked. Formic acid controlled Tropolailaps. It controls Varroa. Many of these other products didn't work. And I think the difference there is that I told you the Tropolailaps mite stays on the brood comb and in the cell. It doesn't go on the worker bee. So some of these other products, especially like these chemicals that move around on the adult bees, the mites weren't coming in contact with Amitraz in those slow release strips. So we got almost no control with Amitraz of Tropolailaps. So I point this mite out, not to scare you, just to say that here it is pictured here. You as a beekeeper are the best line of defense against new and novel things that spread around the world. And so the more you're educated, the more you know about new threats or possible threats, the better you can be and the better you can defend the bees in your area. I suspect that Asian hornets will move across northern Italy and could come your way. I don't know. they like warm climates. So you may be safe in Slovenia. I have no idea. When I first saw small hive beetle in Florida, this is a side story. I saw small hive beetle in colonies running around, and I had no idea what they were because they were on nobody's radar. Like, what are these small beetles? And then a couple of months later, we got reports of colonies dying with beetle infestation. Oh, that's what I saw, but I didn't recognize it because I wasn't aware. So awareness is a good thing, and beekeepers are the best line of defense. So how do you learn about different things in beekeeping? Well, one good way is to come to an ApiMondia Congress. And I'm not feeding you a sales pitch. You hosted a great meeting in Slovenia of ApiMondia, and I heard great things about it. It's one of the few that I haven't attended, and I regret that. I hope to visit you in the near future. But we've moved our meeting in Ufa, Russia to 2022 because of COVID. And that area of the world, they practice forest beekeeping, which is unlike anything else. It's an ancient form of beekeeping. We're keeping bees in the trees and things like that. If you can't make it to Ufa, which you may or may not be able, or if you do make it to Ufa, then join us the next year in Santiago, Chile in 2023. These ApiMondia meetings are a great way to interact, meet new people, and talk bees for 5 days. It's a great event. And I say that with all honesty. So with that, I think I'm going to thank you for your attention, and I'll be on here at the end, and hopefully we've generated some questions. Again, for me, Varroa is probably the #1 pest that we face and interact with. But I think we need to take what I'd call a holistic approach and select bees that can tolerate and live with it. And it's probably not going to be just one single resistance mechanism that you're looking for. So I'd love to see your nice, gentle carniolan bees and enjoy a honey breakfast in Slovenia in the near future. So thank you very much. All right. Talk to you soon.